So the topic of this presentation is the Adventure Radio Protocol. So I'm George, KJ6VU, and this is a project that I took on a while back for a number of reasons that I'll share with you today about what is the Adventure Radio Protocol, how does it compare to other techniques that are used in signaling and emergency communications, or even just generally finding people on the air, and also a hardware project that I'm working on that makes this all possible. So the protocol is all going to be in the public domain. It's published, so anybody can make a controller to adhere to the protocol if you wish to. So well, let's get into some of the details. So what is adventure radio? So let me kind of define that first of all. Adventure radio is really kind of a catchphrase to refer to radio operating out in the field. So it could be a SOTA or POTA activation. It could be that you're out hiking or camping. It could be four-wheeling. It could be any sort of outdoorsy activity where you're going to be using amateur radio to enhance your experience. So the first goal for the Adventure Radio Protocol is to make it easier for radio operators to find each other on the band. So you're not just guessing. So if you go out for a hike and you're taking your handy-talkie, how do you know what frequency to be on? Number two is it supports multiple scenarios. So potentially being helpful in an emergency situation or alerting others that there's a certain kind of activity on the frequency, which doesn't happen to be an emergency, like a SOTA or POTA activation. It's also potentially a technique for getting information about radio systems, repeaters, and such in the area. And also, the idea is to make it possible to do these things. And in particular, when you're trying to get someone's attention and ask for some help, when nobody is actually actively monitoring the radio. So you might say, well, what do you mean by all that? So we'll get into that in a little bit more detail as we roll through the slides. So there's a few key elements to defining the Adventure Radio Protocol. The first thing is to have a common radio frequency, a spot on the dial where people could aggregate and be kind of the watering hole for this sort of activity. The second thing is to have some sort of common signaling standard that could be used to indicate what's going on the frequency. And the technique that I'm proposing for this is to use CTCSS or PL tones. And the reason is pretty straightforward. We'll get into it in a bit more detail, but basically every radio supports CTCSS, but not all radios support other signaling techniques. We'll get into that. And at a very high level, there's really kind of two ways to use this concept. There is what I would refer to as a radio to radio mode or a radio to infrastructure mode. So the radio to radio mode is pretty simple. It just means there's two or more people who want to chat between themselves, radio to radio, but probably in a simplex frequency. And radio to infrastructure means there's some kind of interconnection with either a repeater system, a remote base, remote receivers, etc. So what's the problem that this is really trying to solve? The origin of this really came out of looking at the most popular technique that's used for this sort of thing, and that's called the Wilderness Protocol. A lot of people know all about the Wilderness Protocol. It was defined several decades ago, maybe 30 years ago. And let me describe what that basically is. The Wilderness Protocol says if you need some kind of assistance, then you could follow the following guidelines. First of all, you pick one of the 5 frequencies that are official Wilderness Protocol frequencies. They're the common simplex frequencies on each of the popular VHF bands. So 146.52, 446, 223.5, 52525, and 1294.5. So the question in my mind, by the way, this is where the first kind of issue I have with this approach. If you're going to pick a frequency to make a call on for an emergency or some help, well, there's 5 different frequencies. Which one are you going to use? Well, the practical reality is most people would use 146.52. Why? Because that's the most common thing that everybody's got. So maybe it's not a real big problem, but it is kind of confusing that there's multiple frequencies. The second aspect of the Wilderness Protocol is that you're supposed to make a call one of 4 times a day on the hour at 7 a.m., 10 a.m., 1 p.m., and 4 p.m. So this means if I have an urgent piece of traffic, I would pick one of those 5 frequencies and one of those 4 times to make my call. So to me, that just seems like a pretty narrow chance of someone actually listening. So your best bet would be to go on 146.52 and make a call. In some areas, like urban areas, let's say in the San Francisco Bay Area, Los Angeles, places like that, there's a lot of people that will listen to 146.52, and maybe you can find somebody. But it requires somebody to actively be listening on one of those frequencies, and preferably at one of those times. So it seems like a less than ideal proposal in my mind. It always seemed kind of flawed to me. The second thing, too, is the wilderness protocol was really designed, intended to be used when you have some sort of urgent communications. I've got an emergency. I have a problem. I'm out in the field and I need some help. But it really doesn't support anything else like casual conversations or alerting that there's on-air activities or other things that are very popular today. The second most common approach you see is called a LITS tone. This was promoted several years ago. Primarily, it's used on repeater systems that are monitoring for this DTMF tone. Essentially, a LITS tone, LITS is an abbreviation for long tone zero. What it means is if I'm trying to make a urgent call, I would hit my HT and I would lay on the 0 button for at least 10 seconds. So you'd have a decoder on your receiver or on your repeater's receiver on the whichever frequency that's picked, like 5.2, and you'd wait for this long duration single digit DTMF tone. That doesn't have a lot of wide use at the present time, but it's probably in use somewhere, but it's not widely used. But again, both of these techniques are really intended for emergency calling and not other kinds of activities. For example, I'm going to do a SOTA activation and I want to alert people that I'm on frequency on 2 meters. Most commonly, you'll get on 5.2 and make a call, but that's the calling channel. You're really not supposed to be working stations there. So these protocols don't really support casual operating where you might want some sort of alerting. So that's kind of the best we have at this point. Now, let me get into what the proposal is for Adventure Radio. First of all, we have to pick a frequency, not 5. Certainly not 5 different bands, one frequency, and standardize on that. Now, you can imagine whenever you propose a standard frequency for anything in amateur radio, you'll get nothing but a bunch of people debating. So let's get this out of, on the table right away. There's no frequency you can pick that someone's not going to complain about. That's just a foregone conclusion. So the trick is, what would be an appropriate frequency where people can typically use it? They have a radio and antenna, so 2 meters is probably your best bet. And probably you want to pick a standardized FM simplex frequency. Obviously, 5.2 is not a great choice. So what are the other options that are available? One of the challenges in picking a nationwide frequency for anything is that not every band plan in every coordination area is the same. So, for example, in California, the typical band plan channelization is every 15 kilohertz on the upper 2 megahertz. Lower megahertz 145 is 20 kilohertz. If you go to some other states in their coordination areas, it could be 20 kilohertz spacing, could be 15 kilohertz spacing. So picking one frequency that works on both of these split band plans is really necessary. And now you start to tick through what are the standard simplex frequencies, and you kind of can X a few out right away. 146.4 is sometimes used as a repeater channel, so that's not good. 146.43, maybe, .46, perhaps. 4.6 has been historically used as a remote base frequency, which might not be a bad choice. 5.2, bad choice because it's the calling channel. 5.8 has got merit. We'll come back to that. 4.2 is often used by the Red Cross, et cetera, et cetera. Again, there's no frequency you can pick that you can't find somebody somewhere who thinks it's their frequency. So when I presented this concept here in Oregon, one of the coordination fellows said, you know, every single county and city, there's a whole band plan. And all these simplex frequencies are assigned to somebody somewhere already. Like it's not just a guess they're being used, they're actually assigned to somebody. And so part of this is to recognize that if there's some true emergency traffic, then this would yield to that. But there's not emergency traffic all the time. And so the simplex frequencies aren't overly used. So why not use them? So 146.58 is my proposal for the frequency for two reasons. Number one is it fits the band plan of any frequency coordination body that I've looked at, and I have looked at several. I can't find anything that is normally used on that frequency widely. But the other main reason is because there already is a community of people that do use 146.58. Surprisingly, I found that there's off-road groups, like four-wheeling kind of groups that use it. Here in Oregon, I didn't even realize this, but 146.58 is often used for SOTA activations. So there's actually places where it's already used. Even in Southern California, I was talking to Josh on the ham radio crash course, and he was using 146.58 before I even suggested it, because there's other people who are using it for similar purposes. So it seems like that's a reasonable frequency to pick. If there's a good reason to use something else, that would be fine. But at this point, I haven't found anything better, so I would propose to use that. And 2 meters is the best band for this sort of thing because it's the most commonly used band. Any questions so far? Okay, we haven't even talked about what we'd be doing with this frequency. That's coming up. All right, so how would this be used? The idea is that just having a carrier and voice traffic isn't really good enough. We need some sort of signaling technique to indicate that there's something going on, and that signaling technique could indicate the traffic. There's two obvious ways that could be commonly done in the ham radio world. One is to use CTCSS tones or to use DTMF tones. So in the proposal, what I'm suggesting is that we would identify a small number of CTCSS tones that are reserved for specific kinds of traffic. And it's important not to overly complicate this. So in the base proposal, I'm suggesting 5 tones be used. The tones between 67 hertz and 151 hertz would be reserved for use by the protocol. Could be used, some of the tones could be used for future purposes, but it's better to reserve a whole bunch and not use them than to just populate it with a bunch of stuff you'll never do. And that means all tones at 156 and up could be used by anybody for any purpose they want for their own purposes. So a few of these are really at the core of what the protocol can do. And a few of these are optional. So the most important ones starts out with an emergency calling tone of 67 hertz. Now, these tones are somewhat arbitrary. It's important that you pick tones that are not widely used. And it's important that you space the tones out a little bit. So if people are building decoders, they can, easily differentiate one tone from another tone without being right next to it. So 67 hertz is reserved as the emergency calling tone. 88.5 would be the on-air activity tone. SOTA, POTA, lighthouses on the air, whatever you want to do, Walmart parking lots on the air. The idea behind that is that if you want to find people who are actually working or looking for contacts, then you could silence your radio until there's a 88.5 decoded, and then it could say, hey, there's somebody on the channels looking for contacts. So it's a way to all these techniques are ways to keep your radio muted until a certain kind of traffic comes along. We would reserve 100 hertz for general rag chew. So you could do that without any tone, of course, but 100 hertz for rag chewing. 77 and 123 are what we would call infrastructure tones. They actually would interact with something that's built out. I remember there's 2 modes. There's radio to radio mode and there's radio to infrastructure mode. So radio to radio mode means, for example, I'm going hiking, I'm taking my handy-talkie, my buddies are going hiking, they're taking their handy-talkies. While we're chit-chatting along the way, we'd probably pick 100 hertz as the chit-chat tone. And if somebody had some issue, they could switch to 67 hertz and transmit, and then we would know that there's some emergency traffic. Now, if you do that, what that means is, let's say on the receiving side, you can decide, look, I don't want to leave my radio on 24 hours a day and listen to whatever traffic is on there. I want to filter out for only specific kinds of traffic. Perhaps you only want to listen to emergency traffic. Then you can filter it out except for 67 hertz. The idea behind the ping is if you do have infrastructure like a repeater, if you key up with that tone, a remote receiver, if there is a remote receiver, transceiver, would decode the tone and respond, indicating that there's actually some sort of infrastructure in the area, like a repeater. The 123 tone goes beyond a ping, and it actually could have, let's say, a voice message that comes back to you that says, if the repeater in your area is on 146.94 PL100. And so now you know that there's actually a repeater in your area. So it's kind of an automated information service as well. There are issues around doing that too much. Obviously, you don't want to use the same tone with a bunch of repeaters in a densely populated area and they all squawk back at the same time. That would not work. So there's some planning and coordination that's required for the infrastructure side of things. Okay, so let's talk a little bit about the use cases here. So what would you do to do this? You'd set your radio to the common frequency, set your tone to the mode you want to use, and you just use it. That's it. I mean, that is all there is to the first level of use of the protocol. It merely says, we're just going to use tone signaling to indicate the nature of the traffic. The simplest example of this would be, let's say, for example, you're out camping, and at your campsite, you have a radio, you set it to the 67 hertz emergency tone, and everybody who's hiking around or four-wheeling or doing whatever they're doing, as long as they're not transmitting 67 hertz, you'll never hear them, because you don't want to hear them, talking. But if there's an issue, the person who wants to communicate switches their radio to 67 hertz, and now the base station will hear them. So that's the simplest use case that I can imagine. So it serves a couple things. It allows multiple people to use the frequency, but it also lets people filter out the traffic that they just don't want to hear. Let's talk a little bit about the radio to infrastructure mode. So in this case, this is kind of the next level up of investment, if you will. You could put a auxiliary remote-based transceiver on a repeater. This is going to be most easily done on a UHF repeater, of course. The minimum amount of filtering required. That transceiver could be listening to the 146.58 frequency. You have an appropriate controller that decodes the various tones, and you can configure the controller to take different kinds of action. So, for example, a typical configuration might be the repeater would never hear any traffic on the 2-meter remote radio at all. So if you're on the UHF repeater, you can be chit-chatting away. Somebody could be on the adventure frequency talking about what a great time they're having on the trail, chit-chatting away, nobody ever hears each other. As soon as somebody on the adventure frequency on 5.8 changes to 67 hertz and transmits, the ARP controller decodes that, says, 67 hertz, there's an emergency, I'm going to pass this traffic to the repeater, and it enables the path to the repeater. So you transmit with 67 hertz, then the UHF repeater lights up, and whoever is transmitting on the 2-meter frequency would come out the repeater. And if you have your repeater configured to transceive back on 2 meters, you can then talk to the other person out the 2-meter radio in kind of a traditional remote base use case. Obviously, there's a lot of configurable parameters here. You could configure your repeater to maybe just send an alert tone, or just send the receive audio not in transceive, or just be in transceive mode. So, that's all possible. The other thing that you can also do is, if you have any kind of internet access at the repeater or available to the repeater site, you can also detect that 67 hertz tone, and a computer at the repeater site could then take some action. So what could that action be? The simplest thing is to send a text message. So if somebody keys up on this channel on 67 hertz PL, what happens is that's decoded. The Raspberry Pi or computer at the repeater site says, aha, there's emergency traffic. I'm going to text the following set of people that are on my text list, and your phone beeps, and the message is there's emergency traffic on the adventure radio frequency. So now you can either turn on your transceiver or go to your repeater and turn on the remote base, or just turn on the repeater and maybe the remote base is already passing the traffic through there, and you're good to go. This really overcomes the fundamental limitations of the Wilderness Protocol. Again, the Wilderness Protocol requires that you actively listen to the frequency at a particular time of day for the traffic. In this mode here, I could never have my radio on. My repeater or remote receiver could detect the traffic and alert me and then I go turn on my radio and figure out what's going on. So it's much, much more practical than the other techniques. So that's the basic idea. You can continue down this path and make it more sophisticated and enhance it over time, but that's really the essence of the proposal. So again, there's sort of two levels. There's radio to radio, doesn't require any infrastructure. You don't need to buy anything. You just take the radios you've already got and use them. The infrastructure mode requires some infrastructure. I've had several people make other interesting suggestions. One fella said, "Do I need a repeater? Can't I just put up a all-star node and a transceiver on a mountaintop or at my home or on a hilltop?" Absolutely. So you can have a 2-meter transceiver with the ARP controller and an all-star node, and you backhaul over the internet. Would work perfectly fine. You don't need a repeater to make this happen. You can have multiple satellite receivers. So you can have, everybody in the community at home has a receiver listening to 5/8, listening only for the emergency tone. And if they decode it, it just sends a message over the internet to a server somewhere that redistributes it as an alert to the membership. You don't even need to have a high site. As long as you have a bunch of, it's like little cells listening for the tone, you can detect the tone. So there's a lot of possibilities for how you might build the infrastructure out. So to wrap up the idea here a little bit before we take questions. So again, you could do this a couple different ways. You could do radio to radio, no controller, no infrastructure, just use what you've got. The second option is you could build your own decoder and implement it yourself, which is perfectly easy to do. There's nothing hard about that. And the third option is I'm building a controller that supports everything I mentioned plus some stuff. So this is a picture of the prototype. I can show you one here live on the bench. Basically, this is a 2-port device. One port goes to the remote base radio that's listening on 5.2 or 5.8. The other port goes to a port on your repeater controller. And the unique thing about this controller is that it has a scanning PL decoder. What that means is typically PL decoders are programmed to listen to a particular tone. So I'll take a little circuit board that's a PL decoder and I'll set a dip switch that says, listen for 100 hertz. And if you hear 100 hertz, pull this pin low. That's fine if you only need one tone, which is what anybody needs on a repeater. For this application, you want to be listening for multiple tones potentially, maybe many, many tones in a very sophisticated implementation. So to make that more practical, I designed a scanning PL decoder that listens for any tone between 67 and 141 hertz. If it sees any of those tones, then it takes action. And each individual tone's action is individually configurable by the user. So what are the potential actions? So one action is that the controller sends a string out a serial port to something else. So to a Raspberry Pi or a PC or whatever you like. And in that string, it says that the tone 67 was decoded. You computer decide what action you want to take based on that information. And no matter what tone is decoded, that information is sent out the serial port. Second thing that the board does is for any of the tones that you identify as being an alert tone, there's also a open collector pull to ground. So you can just pull a pin to ground and again, take some sort of action that you want on the other side of that on a computer, Raspberry Pi, what have you. There's also an LCD display. If you happen to be at the controller, you can see what the tone is that's being decoded by looking at the display. The other configurable feature is since you're taking audio from the remote-based receiver through the controller and passing it to the repeater and vice versa, the audio path and the COR and PTT signals are gated by the controller. And you could decide for any of those tones, which of those tones would pass audio and COR signal to the repeater controller. So the default would be only 67 hertz, the emergency tone, because if someone is just doing a ping or there's just chit chat traffic or there's a soda thing, you don't want that triggering the repeater. So those are filtered out. Only the 67 hertz emergency tone would connect to the repeater and pass the audio. But that's totally configurable. That could be done for any of the tones. The last thing, though it's not at all part of the protocol, but is on the board anyway, is a DTMF decoder. So in addition to decoding the PL tone, the board can also decode DTMF, and whatever DTMF sequences are decoded are passed over the serial port to the PC on the other end to do with it as you please. So that's the basic idea. So you can see there's a board here. I can show you one live if you like. So right now the current status is that it's in what I would call beta. I've got one unit up and operational here in Oregon. I've got another one on the bench, and I'm in a perpetual firmware refinement mode. So the hardware is pretty much done. The firmware, the base alpha code is working. Now it's sort of in the beta version, which means I'd leave it on a hilltop, but it's not got every feature I want yet. So I'm still baking a few more features into it. My guess is it'll all be done in the next couple of months. So that's the current status. A couple of references. In order to promote this idea and to publish the open source parts of the protocol, I put up a website, which is adventureradio.info. If you go there, there'll be a definition of what the Adventure Radio protocol is, what the specific tone assignments are in the protocol, and pointers to resources like this presentation. We did a ham radio workbench episode with Rex KE6MT, who's the SOTA coordinator for Southern California, well, for Northern California, I guess. And Rex is a big proponent of this. And so we had him on the show to talk about SOTA and the concept of the Adventure Radio protocol. And so there's an audio podcast you can listen to. There's an interesting blog by a guy who I don't know, K0NR, who heard about this and wrote a little article about it, saying, hey, this is a great idea. So that's cool. We have a Ham Radio Workbench Discord with multiple channels. One channel is for the ARP, and we've got some conversation going on there, so you can go converse with us and others on the Discord. And also I did a show with Josh from Ham Radio Crash Course all about this. And so you can watch this whole presentation again, if you didn't get enough of it the first time, at the HRCC YouTube channel. So with that, I think I'll stop here and take any questions.
Okay. Be nice if I unmuted myself. Well, I am unmuted. How about that? Hi there. Okay, Gene, go ahead. You got your hand up.
Yeah, good evening, everybody on the meeting. Glad to see everybody up there. My question is, if I have my radio set to one of these frequencies with or without the PO tone, would it be appropriate for me to, as soon as I turn on the radio, to do a test to see if, basically an announcement, hey, I'm N3XUS monitoring this frequency. Would that be appropriate or not?
Oh, 100%. Absolutely. So this is not intended to restrict anybody's use of the frequencies. All the frequencies are there for all of us to use. What it's really intended for is to augment that by providing some additional services that could be very useful. So we really want to encourage people to use the frequency for these kind of activities. Like if you go somewhere, let's say you go hiking somewhere and you want to be able to find somebody else, like in a simplex channel, you're going to probably guess beyond 5.2. But we're trying to encourage people to listen on 5.2, but also listen here on 5.8 and use it as soon as you want to, and see who else is on the channel.
Oh, okay, I understand. Thank you very much.
Sure.
George, could you lower your desktop?
Can I lower
Your
my
share?
desktop? Oh, sure. Sorry.
It works out better in the video because you're a small picture with that desktop up, and everybody gets a full screen.
Oh, I'm so sorry.
Oh, that's okay, not a problem. Okay, anybody else got any questions out there?
Gail wants to know if we can see a demo.
Sure, we could do that. Let me see. Let me change my camera. All right. So hopefully you can see my my
Yep.
workbench here. So this is the latest version of the controller, and then I have an LCD display that's plugged into that. So you can, if you put this in a chassis box, you can mount the LCD on the front so you can see what's going on. There's 2 ports on the board. This is the primary port that goes to the remote-based radio, the VHF radio, and then the second port would go to the repeater controller. There's not a whole lot you need to do to configure it. I designed it with all through-hole components, so anybody can solder it together. There's a few pots for setting levels, and that's about it. So, so let's see. What I don't know if you could see. Yeah, I've got a dumb terminal screen up here. I'd show you how to do the configuring, but I don't know how to show that at the same time as my video. Okay, so we'll just go this way. So I'm going to start out. You can't see this, but I'm going to set this up so that 67 hertz is triggering an emergency tone and other tones won't. So let's just start out with my, if you can see the screen on my handy talkie. I'll set this to, let's say, 71 hertz. And when I key that up, nothing happens. I mean, it'll detect there's a carrier there, but that's about it. If I switch over to 67 hertz and key up, what'll happen is you can see on the LCD, it says 67 emergency. LED indicates, you probably couldn't hear it, but you could hear a little relay click in the background. So while I'm keyed up, the dry contact relay, which comes over here, is active. And then when I unkey, I'm going to put the radio near the microphone. So,
Heard that.
so when I unkey with 67 hertz, there's a tone that I can add to the unkey so that if that's going over to the repeater, if you're listening on the repeater and the remote base is engaged and someone unkeys on 2 meters, it'll make a beep. And that's all programmable. So like I can go in here and on the dumb terminal and say, I want to set the tone for 67 hertz to be tone pattern number 1. And now when I key up, I can get a different kind of tone. So a different kind of alert tone could be programmed. So that's nice because you might have, let's say, 3 beeps for an emergency and a single beep for non-emergency, but still pass that traffic if you choose to the repeater if you're using a repeater. The other things in a demonstration, it's kind of hard to see, like there's an open collector output that's pulled to ground. When that's active, it's kind of hard to show it here physically. But that's happening here as well. The way you interface to this to program it, there's a serial port that comes out to one of these 2-pin terminal blocks. And so this is the programming device. So this is a USB to RS-485 converter. And so you just screw these two wires in here, plug this into your PC, bring up a dumb terminal like PuTTY, and you could just type command line parameters to configure this. So that way you can say which one of the tones would take which kind of action or what kind of tone telemetry is it, and so forth. And you can program all of that in through the serial port. So that's basically the demo.
Okay. Tom, you got your hand up?
Yes, sir. Can you hear me?
You're fine.
Just wanted to make the comment that anybody who's monitoring anything that might involve a wilderness emergency, especially, should keep the number from the North American Search and Rescue Coordination Center handy, because they can find out whose jurisdiction that is with a couple of strokes on the keyboard, whereas you might take for the person calling for help, 1 year and a day to try and figure out what jurisdiction it is. They might have given you a place in a national park. Well, it's the national park, but which national park, and so forth. North American Search and Rescue can be on the phone to the park before you finish speaking. So if you're going to monitor for this stuff, keep the number handy. That's all.
Okay. Bill, you're up.
Yeah, nice demonstration. Curious, George, if that is receive only or if it has transmit capability to key a transmitter back, and if so, does it have IDing built in?
Actually, it does it the this one does not transmit PL. That was actually kind of a point of debate early on when I was talking to some other folks about this idea, and we could add PL to the transmitter. It can do CWID. Actually, the firmware is built into it to do that. So that's certainly doable. But currently does not support PL encode on the output, but that'd be pretty easy to add.
So you could tie this in with a software-defined radio, possibly.
Oh, well, sure. I mean, you could, it'll interface to any kind of radio. I mean, typically what you do is hook it up to the discriminator output. If you're just going to go build this today, you would probably get something like a Motorola CDM 1550 or something like that, where you have discriminator receive audio coming out. It'll go right into this. And then the carrier operated switch logic output goes right into this. After that, this takes care of everything else. This would do the PL decoding and the or the DTMF decoding if you want to use that. That's all built into it. On the transmit output, you have a you'd probably drive the modulator in the transmitter, and then pull the PTT line. It's an open collector line to ground to actually key the transmitter. So those 4 signals in ground are on the back of Motorola transceiver. That'd be like a perfect fit for something like this.
Thank you.
Okay, sounds good. Barry, how we doing?
Dean has a question in chat. Are there any recent reports of these protocols being used for emergencies through the media testimonials, etc.?
No, no, this is new. We started talking about this about 2 years ago. So Rex and I and some others, and before we really promoted something like this, I wanted to make sure we had some actual deployments of the hardware somewhere actually working. And there really was hardware to support the full infrastructure side of it. And so we just got to that point at the end of last year. So the first repeater with it went up here in Oregon late last year. And then we've got a bunch of other folks in the region who are interested in it. So we'll probably look at putting up a handful of them in the next year here. But it's brand new. I mean, it's like new. Probably the one thing about this that is not that new is the use of this particular frequency, 146.58, is, as I mentioned before, frequently used in various parts of the country. It's not standardized or anything. You won't find it on a frequency guide, I don't believe. But there's kind of a de facto use of it for a variety of outdoorsy kind of activities as an alternative to using 5.2.
Okay, great. That's everything in chat, then.
Okay. Thank you. Anybody else got your hands up or? Okay, open it up for general conversation. Anybody got any comments? Crickets.
So really the punchline is what we're proposing is pretty simple. This is not a complicated topic. And it all really starts out with, let's agree on a place on the band where we can have some coordinated kind of activity for these kinds of, outdoorsy activities. And let's take advantage of technology we've already got that is that could lead to some more interesting automation, and see if we can build out some infrastructure to support it. So I think success of this is measured in 2 ways. One is, does anybody adopt the tone signaling and frequency for just radio to radio operating? Forget the controller and all the infrastructure stuff. And it turns out actually that's already being done in some areas. And so we want to foster that. And if we do just that, actually it'll be a move in the right direction. To me, the more interesting thing is what can you do beyond that? So to me, the idea that somebody could send an alert by just keying up the radio they've already got, and I, as the receiver of that alert message, I don't have to be listening on my radio. I can be anywhere with my phone and I can get a text message. So that's pretty compelling. And it's not hard to do that. That's all very easy stuff to do, very much, in our grasp today. So that's the idea. And it's not a foolproof thing. It's not, I don't intend for this to be a complete solution for an emergency situation. If you've got a Starlink terminal or a sat phone, or like, go use it, please. This is not meant to be a replacement for that. It's meant to augment the stuff that we've already got to add one more level of utility. And it's not just meant for emergencies. It's meant for, in fact, I suspect probably 99% of the time, if not more, it's going to be used for casual operating. For example, I'm a soda chaser. I don't want to listen. How do I know when someone's on the air? I listen to 5.2. Well, I don't want to listen to 5.2 all day long. I'd like to filter out everything except the guys who are doing soda activations. Well, this way I can just listen to this frequency, set my tone to 88. I don't hear anything. There's no activity. And as soon as somebody's doing a soda activation, I'll hear them. So as a chaser, that's really convenient. So that has nothing to do with emergency communications. That's just making it easier to find each other for a certain purpose on the air.
Gene, go ahead. Got your hand up.
Yeah, one last question. When it comes to using these protocols, are there any when it comes to HTs, are there any antennas that might be better for reaching out as a substitute for the stock rubber duck?
Oh, that's a religious question. So the standard answer is throw away the antenna that comes with your radio and go buy a good one. In my personal opinion, I think that depends on the radio you bought. My experience is with any of the good radios like ICOM, Yaesu, Handy Talkies, for example, the stock antennas are actually really good. And the ones that you probably want to upgrade are the cheaper radios. Most of the Chinese radios put on a 50-cent antenna, and it's probably okay, but could be better with a decent Comet, Diamond, whatever antenna. And then it's just a matter of like how what's ungainly, what's convenient for you. One other thing to mention about Handy Talkies, besides the antenna thing, is one of the reasons to use CTCSS or PL tones as the tone signaling mechanism, not DTMF, is that a lot of radios today don't have DTMF pads. Okay, so the first thing you do is go buy an ICOM Handy Talkie. Go spend $500 on an ICOM Handy Talkie. There is no DTMF pad on that thing for $500. So that's kind of a wake-up call. Now, a lot of the Yaesu Handy Talkies, I think all of them, have DTMF in one form or another. Even this, FT5 has a kind of a DTMF pad on the screen, which is fine, but the ICOM radios don't, and using the tone memories is not really practical. So plus you buy a commercial radio, you go get a whatever Motorola radio, it may not have a DTMF pad, or you get some Chinese radio, a lot of them do and a lot of them don't. So that's one of the reasons not to go with DTMF, even though the decoder I built will decode DTMF too if you really want to do that, but it's not a requirement for the protocol.
I've got some ICOM handhelds here, and they don't have the pad, but you can program it in. In other words, you can.
Yeah. So that's that's true, but it's kind of impractical because you would have to kind of pre-program whatever sequence in advance. It's kind of not really easy to do it on the fly. You can do it, but it's kind of a pain, and you really don't want to have to figure it out, when you're out in the field. So, it's doable, but it's not ideal. So, I mean, most of the radios will at least have DTMF memories, but I've used that a bunch, and I just find it irritating at best.
Okay.
And with this method, every radio's got a bunch of channels. You would just preset channels with different PL tones. So you can have like the chit chat channel and the emergency channel, and and then all they're doing is changing the tone. You can also decide channel by channel if you want to decode PL or leave a carrier squelch on your receive end. So for example, this is kind of getting into the weeds, but I would recommend on the channel you program with the emergency tone, it's transmit only, and you're not decoding 67 hertz because you want to be able to hear all the traffic on the channel. So just as a word of advice, when you're using a tone for an emergency purpose, I would not use tone decode. The other chit chat purposes, you could. It's optional up to you.
Very good. Anybody got anything else out there? This has been a good presentation. Thank you, George.
My pleasure, Dan. Thanks for the time. Appreciate it.
Okay. Boy, okay, Dennis, you got your hand up. Go for it, sir.
Oh yeah, I just want to say this is great, great presentation, a great concept. I like, George, you sent the website to me earlier, and this is just really cool. And I've already been thinking of some applications here in our group to use this. So it's good timing. So I look forward to seeing more on this. But so thank you for coming aboard and doing the talk tonight for us. And we want to get you back again for a couple of more talks that you have. So
Oh, I'd love to. Yeah, my pleasure. Thank you, Dennis.
we've got some days to fill up in the future here. So we'll get back in touch with you and we'll get you back here again. So appreciate you coming down here and doing this.
For sure. I've watched a lot of the presentations. I really enjoy them. So I very much appreciate the work that you guys do to put this together, get some great speakers.
Well, likewise, what you do with, I don't know that we should have done an introduction. I think I don't know that a lot of folks know who you are with Ham Radio Workbench. I mean, what you do is what you've been doing for a long time now is just fantastic. So really enjoy Ham Radio Workbench a lot.
Thank you.
I
think it's good to promote that here as well.
Well, what I do is I put a link, and when they send out the invitation, I put a link to the person's QRZ page.
Right.
And they have a pretty good layout there that is lengthy and well-defined. Every once in a while, I find somebody don't use that at all, and so that's a problem. But most of the time, the QRZ page does a pretty good job.
So I have a very short QRZ page because I've got a pointer to a podcast. So Eric from the QSO Today podcast interviewed me some few years ago, and so I figured, well, I don't have to repeat my bio. You can go listen to this interview, and you get everything and then some. And what Dennis is referring to, in case you guys don't know, so I'm the host of a podcast myself called the Ham Radio Workbench, and we just crossed over our 200th anniversary episode this week. So the shows just went live, and it's very much geared towards hands-on ham radio. We do a lot of shows about technology and building and portable operating and that sort of stuff. But our real our goal with the show is to talk about topics that would be of technical interest to hams, whether you're a beginner or an advanced. We a lot of times we'll bring on people who are real experts at something, and so sometimes it kind of goes over our head. But we try to translate that for everybody. But we don't dumb it down. If we go in to talk about, how does a mag loop work, we kind of get into it. So we don't profess to be experts at everything, obviously. So we get experts to come on who do know a thing or two, and so then it's useful. But we have shows on 200 shows to listen to. We joke around saying that if you have a big lawn to mow, we're the podcast for you because they tend to go on for a while.
Well, I'm hopefully I know it is. Be sure to send me your slides after this so we can get that information out.
Sure.
Okay, anybody else? Barry?
We're good in chat.
Okay, he's my eagle eye guy. Every once in a while I miss something in chat, watching everything else, and he takes care of it. He's also the bad guy. We get a bad, and I think in the 3 or so years we've been doing this, it's always happened once. When we have a bad actor, he can push him out, gone. Anyway, I personally, the country you see behind me is, I have a cabin, and I was at our cabin and out running around my little Honda 90, came across a fresh started. Somebody threw a cigarette out. We had a forest fire started. And so I picked up my handy dandy walkie-talkie, had a heck of a time. I mean, what I did is at the cabin, I got a crossover radio crossband. So it goes right into the repeater. And I had a heck of a time getting somebody that the fire was going pretty good before somebody finally came on.
So Dan, that's kind of this scenario I'm trying to help with, where we complain that there's a lot of times repeaters, nobody listened on them. And so if you get on there and call for help, there, unless you're listening, no one's there to hear you. So having some kind of tone signaling aid to do that seems like a good idea, where, the 5, 10, 20, whatever people on the mailing list, the text ring down list would get the message that there's something going on. Because, we're busy every day. We're working and are dealing with our kids and families and whatnot. And unfortunately, you can't listen 24/7 to the radio, perhaps nor do you want to. So that would, that could make it very useful.
Yes, yes. Okay.
Yep.
Anybody
Memo,
else?
you had a green light on it. Is there any chance to make that turn to a red light when there was an emergency transmission?
Oh, you can put in whatever color LED you want. Or there's a dry contact relay that's on the board. So whenever, and you decide which tone you want to actually activate the relay, any one of the 24 tones that it could act on. And you can hook that up to whatever you want. You hook it up to a klaxon, you can hook it up to a big light, you could hook it up to,
Siren.
3,000 volts to jolt your chair, whatever it takes to get your attention. I think Dennis liked that one.
Someone wants to tie into WinLink.
Pardon me?
And this tie into WinLink.
Can it tie into WinLink? Well, I mean, once you get to a computer, you can go to anything, right? So, like for example, if you triggered an event, we send a string to out the serial port. So a receiving computer could take that string and act on it. So if that computer could send an email or a text message or whatever. So you can send an email to your WinLink account if you want to, I suppose. Hadn't really thought of that, but yeah, I mean, so part of this is to make it kind of open and easy to interface to other stuff. And by having a physical pin pull or an ASCII string going to a computer, once that data gets to the computer, you can do whatever you want, right? You can write a little program to do anything with that information. I didn't go into much detail, but the informational response with the 1, 2, 3 tone is intended to go the other way around. Like we have one group who's interested in putting this in a place where it snows a lot. So they want to put weather information out. And what they'll do is that they want to get a recording of the weather forecast, put that on the computer as a WAV file. And when you punch the 1, 2, 3, it plays that WAV file. And whenever they change that WAV file, when the weather changes, that you get a new forecast. And so that's kind of a cool application, So I think there's a lot of potential. And all this that I'm describing is something that is very easy to do on a PC with a little bit of programming. So it's not a very complicated thing to make these interfaces work.
All right. Sounds good.
Thanks very much.
I think you're on the right track, sir.
Thank you, Dan.
Okay. Well, anybody else got anything? I don't hear anybody. I don't see anybody. Comments? Okay. We can wrap this up about 5 minutes early, it looks like. This has been a good one, George.
Thanks, Dan. See you soon then with another topic.
Yes, thank you very much. We'll be in touch. Trust me.